Page 82. Headphones or subtitles, please. Please remember to show your work. Notebooks are a good place for this. No work, no password. Alright. Show how you could use the commutative property to simplify the evaluation of this expression. Okay, remember, commutative property tells you that you can switch things around. Commutative property says that 2 plus 3 equals 5, and 3 plus 2 equals 5. You can change the order of things. It works for addition and multiplication. So, I see that these two have the same denominators, so I'll put them together. Negative 7 over 16 minus 5 over 16. I see that this is negative here, this is negative here, this is still negative, this is still negative. So 7 plus 5 is 12, so it's 12 over 16. Now I know I can simplify 12 over 16 by dividing them both by 4. And that's going to give me 3/4. Now 3/4, remember it's going to be negative. So here's 1/4, negative 1/4. So negative 1/4 minus 3/4. Okay, put those 1 plus 3 is 4 equals negative 4 over 4, which equals negative 1. That's one way you could do that problem. Another way is add these two and keep it negative. So you have negative 12 over 16, just like we had right here. Okay, you had negative 12 over 16. And now let's convert this negative 1/4. Change the denominator by multiplying by 4. So that's going to give us negative 12 over 16 minus 1 times 4 is 4. 4 times 4 is 16. Now we have common denominators. So now 12 plus 4 is 16. And that equals 16 over 16. Remember, it's negative, and that equals negative 1. So either way, you get negative 1. You could combine these two and then simplify the fraction. It would give you the same denominator as the original, as this original number. But anyway, the commutative property allows you to rearrange the add-ins. So let's type that in there. Sorry about the spelling. Okay, so this right here never mind. This problem doesn't look like an addition problem because you see subtraction, right? But remember, all of the signs are the same. It's negative, negative, negative. So it's going to be same signs, add and keep. Okay. The temperatures for 5 days in Kaktovik, Alaska are given below. Here they are. Temperatures for the following week are expected to be 12 degrees lower every day. What are the highest and lowest temperatures expected for the corresponding 5 days next week? So 12 degrees lower means that you're subtracting 12 from all of those. Means minus 12. Okay? These are already all negative. And because they're negative, when you subtract 12, they're just going to get more negative. So let's find the highest and the lowest temperature. Okay, so these are all cold, but there's relative coldness here. So here's a thermometer temperature gauge number line of math. So there's 0. 19.6, we'll put that right here. Okay, so we got that one done. Now negative 22.5, we'll put that right here. So that one's done. Now negative 20.9 is going to be somewhere in between those two. Okay. Negative 19.5 is going to be here. That one's done. And then negative 22.4 is going to be here. Okay, so look here. This temperature right here is the highest temperature. Not a very warm high temperature, right? And then this temperature here is the lowest temperature. But now we need to subtract 12 from those two temperatures. But remember, it's already negative. So subtracting 12 is going to make it more negative. So negative 19.5 minus 12 so it looks like the highest temperature will be negative 31.5 degrees Fahrenheit. Negative 31.5 degrees Fahrenheit. And then we'll find the lowest temperature. So this is the low temperature, so take that temperature and add negative 12 to it, or subtract 12, because adding a negative is the same as subtracting, right? So minus 12 from there, it's 0.5 here, and then 4. So it looks like the low temperature will be negative 34.5. Must the difference between two rational numbers be a rational number? Explain. Let's work this problem with some examples. Okay, we know difference, we know that means subtraction, right? Rational numbers, those are fractions and decimals. So for this problem, we'll use a fraction. So 5 over 8. There's a rational number, and here's a rational number. Okay, so the difference, we have the difference right there for subtraction. We have two rational numbers here because we have two fractions. So will the answer to this problem be a rational number, or will it be a fraction? Explain. 8 and 6. What's the least common multiple? Is it 48? 8 times 6 is 48. Is that the LCM? Nope. So use 24. 8 times 3 is 24. 5 times 3 is 15. And then 6 times 4 is 24. 1 times 4 is 4. So that equals 11 over 24. Okay, so since fractions are rational numbers, and when you subtract two fractions, you get a fraction for your answer. That means that the difference between two rational numbers will be a rational number. If I make this size 14, will it fit in those lines better? Yeah, a bit. Evans said that the difference between two negative numbers must be a negative. Was he right? Use examples to illustrate your answer. Okay, well look. Here's a negative 7. Here's a negative 9. Difference means you subtract, so put in a difference right there. And you know that subtracting a negative is like adding a positive, and that's going to be 2. So was he right? No. No, he wasn't right. Okay, so think about this explanation. If you subtract a negative from another negative, that's what we did. We had negative 7 and we subtracted negative 9, but we knew that subtracting made it positive. That gave us a positive difference because the absolute value of 9 is greater than the absolute value of 7. So that made it a positive answer. Alright. Thanks for watching.